Hi guys, welcome to this series of Java tutorial simplified. I am Lamoha Igoroje, and I'm basically going to be using this series of tutorials to target beginners or people who want to start learning how to program in Java, computer language, right? And also I would be targeting people who already kind of know how to program, probably just got into programming in Java, but don't really understand certain things or find it difficult to remember certain things. So as much as possible, I'm going to simplify it to the best of my knowledge so that we can understand it easier, and we can go through writing programs basically to help us do and achieve as much as we want to achieve. In this series of this course, I'm going to just give us a brief introduction. I'm not for you to want to learn how to program in Java. I'm assuming that even as a beginner, you already know certain things about computers, you already understand certain terms, um, about why you want to even do Java programming in the first place. You already know what programming is all about. So I will just take us through certain things that we have to know, however, when it comes to Java programming. So one of the things I'm going to be talking about today is the learning curve. So basically, Java programming can seem quite difficult at first, and it requires us to have like good problem solving skills. You need to have to know how to paint this mental picture of how the computer works to be able to program well. And that's why I said at the beginning that I expect us to already be conversant with how computers work for you to even want to start as a beginner in Java programming. And the next thing that I want to point out that it may seem quite hard at first, but you need to just be persistent, and then at some point everything would make sense. So I'll give you a little story. When I started learning how to program in Java, I found it very difficult. Like I learned it during my doing my masters at the University of Glasgow, and basically while when I started learning how to do my Java programming, I had come across Java programming before, don't get me wrong. I had come across certain concepts about programming before, but as at that master's period was when I had to like really put it into practice. I cried. Like at first it just couldn't make sense. Like I have good problem solving skills, don't get me wrong. I always see myself as someone who has good problem solving skills, but for some weird reasons, I just could not understand what was going on at some point in the beginning. And it just felt strange, like what's all this? But one day I just everything just clicked, and it was like, wow, like really, oh wow, like now this makes sense. This is what they were talking about. Oh, this is this, and everything was just I just kept doing it. I found myself doing Java, like writing Java programs, just do the assignments, give myself works to do in Java. Like everything I do, I basically just try to be persistent, consistent rather, sorry, excuse me, with um my Java right programming skills, yeah? And with time everything makes sense. So don't be too hard on yourself. That's one thing I will tell you, because for me, I was a bit hard on myself at the beginning by breaking down into tears that, oh, it's difficult to understand. But I'll just assure you, don't be too hard on yourself at the beginning. You would get it very soon. It will click. Now, the Java language, basically, it's a high level language. It's just forget about all the the things I've written on here that you can see in the slides. They're all true about the language. It's simple, even though some people may argue with you that and say that some other languages are simple as well. That's true. But when I say it's a high level language, the thing about, for example, taking Python. Python is simple, but at the same time, Java, as compared to low level language that the computer understands, the computer doesn't understand sentences. Like you writing a statement like, if print this statement for me, and you put it in strings or in quotes, yeah. In Java, we'll see more about that later. It's a high level language. It's something you can read, that just reading it you already kind of, you can interpret it, so basically, that's why I'm referring to it as being simple. It's not a case to argue, oh, is it the simplest high level language there is? It may not be the simplest high level language there is, to use in doing what you want to do, but it's a high level language. And one advantage, or one general advantage of high level languages, computer languages, are the fact that they are simple, they are human readable. Yeah. So basically, the Java language is a high level language. Just remember that it's safe. It's got a lot of rich libraries, packages that we can use in writing it. So basically, one thing, it's an object based language. So one thing I would just tell you to remember when you want to do Java programming is that it is all about objects. Almost all object oriented programming languages are about objects, manipulating objects. For example, I'm just going to give us an example. I want to make a cup of tea. I have my cup, it's an object in Java. I have my water, it's an object in Java. I have the kettle, it's an object in Java. I need my cup, the kettle, and the water, and my tea. I would represent each one as their own unique individual objects. Yeah? So we'll talk more about objects, but just remember that everything about Java is relating to objects, handling objects, creating objects, working with objects to get what you want done or to achieve your goal. So basically, I want to write a program, like I said, back to my example, sorry about digressing. I want to write a program about making tea, and I want to give the computer a set of instructions to make tea for me. So basically, what I have to do is to create all my objects and manipulate the objects in the process of making tea. I tell it, the first thing is put the water object in the kettle object, you boil, you press something on the kettle object that boils, and then it boils, and you put it in the cup, and you put your tea bag, and you have your cup of tea. So it's manipulating the objects, giving it a set of instructions to follow to achieve your goals or the thing you want done. So basically, the codes you write, the high level language, the Java codes you write, let me put it that way, as simple as possible. The Java codes you write need to be translated into what the computer would understand, like into the computer understandable format. So basically, if you already have a background, like I said, people who want to even start programming must have a background about computers. Computer itself has a language, a binary language. Computers make use of ones and zeros. So we need to be able to translate whatever high level instructions you're giving, or understandable human. When I say high level, I mean it's understandable to humans. You have to be able to translate this into the machine format. So for Java, it needs to be translated into the low level programming language. And the thing responsible for translating a Java program is what it's called the compiler. So the compiler basically is just to take your codes, translate this into what the computer understands. Yeah? Check for, in the process of compiling it, to check, okay, are there any syntax errors? We'll go into more about what syntax errors are. And eventually, when the program is free of these errors, it would create the program in a form that the machine, the computer understands, called the executable program. Yeah. And then this is what is now run on the computer for the computer to perform that task. So every programming language has its advantages and disadvantages, like I said. For Java, for me, just one thing I've learned about programming languages is depending on what you want to achieve and depending on the ease of the language for you or your understanding of the language, use it. Use whatever is best for you. Use whatever makes more sense to you. So I'm not of the point, and use whatever language would best suit that problem you're trying to achieve. For example, you may want to design or just write a simple program that does some statistics. You may not want to have to go into writing Java codes for that. You can use other high level languages like Python, which is good for statistics. So, depending on the scenario or whatever you want to achieve at that point, you use the language best for you. But one good thing about Java programming is that it's quite common that whatever can be done in another language, there's a Java way of doing that thing. So most times it may take you installing or using making use of some other tools. We would see more about that. That's like more of saying integrating different other programming languages or packages, to achieve what you want. We'll see more about that in later courses on this series. But just be consistent. That's all I can say. And whatever you want to achieve, use what works best for you. So let's move forward. So basically, Java program language, Java, can be written, I'm just going to refer to it as Java from henceforth. Java can be written in a normal notepad, yeah? But then you have to be able to have a compiler that will help you to compile that codes you've written. And you would have to have a way of integrating the libraries you want to use. Yeah, you need a way of launching. So instead of having to do all this from your terminal, like writing codes and going to your terminal trying to compile big jargons, just get what we call an IDE. It is an integrated development environment. It will make your life a lot easier and simpler when it comes to programming in Java. So basically, there are a bunch of IDEs. So, like I said, get an IDE. Trust me, it makes your life easier because an IDE would be able to it has an editor for you to actually write your codes in. It would compile, so it does everything. It will show you your errors when it's compiling. It has all the libraries automatically included, like the Java libraries, the default libraries that you need, and you can include new libraries if you need to. When I say libraries, those are like basic just think of libraries as like files that contain already written instructions or functions or methods that you need to apply. So you don't need to write that method from scratch. You just call it from that file. Yeah, so just picture a library, a literal file. Yeah, so it IDEs already have and or come with the default Java libraries, and you can, like I said, import new ones into the IDE so easily without any stress, and it keeps track of your programs. So in these tutorials, I'll be making use of the Eclipse IDE. When it comes to Java programming, there's the Eclipse, there's the NetBeans, you have IntelliJ, you have even cloud-based IDEs. So there's the Trinket. I've not written that in here, but there's the Trinkets you can use online. There's some um so basically, when I say cloud-based, means you access it by just using a URL. So if you just go to Trinket, Google trinket.com, I think it's trinket.com, or just Google Trinket, and then you access it through your, so that particular ID, you're going to write your codes in your browser, and the compiler is inbuilt, the libraries, the default Java libraries are inbuilt, so you can run. But the disadvantages of using cloud-based IDEs is that I'm not too sure about their capabilities of integrating other libraries. Yeah. So it may take you a longer process than it will in Eclipse IDE, for example, which you'll be using, and we'll be seeing how to add new libraries. So, like, just like the programming language, like I've said, use the programming language you're more comfortable with, and for the purpose you want to achieve, whatever purpose you want to achieve, make sure you're using the right language that would achieve that purpose. However, Java would help you achieve a lot of purpose you want to achieve, a lot of things you want to achieve. You can achieve that with Java as well. The same way, when you're picking an IDE to use, make sure you use the one you're more comfortable with, or you can try one or two and you'd see, oh no, I prefer to do this in this. NetBeans provides me a process of just dragging and dropping. Like if I want to create a form, NetBeans will give me a process of just easily drag and drop different icons like a text box, a button, and then it automatically generates, it has its advantages. Eclipse, on the other hand, has its own advantages. So use what is best for you or what you're more comfortable with. But I'll be using Eclipse, and I would suggest that you download and install Eclipse on your system for use in this our Java tutorials. So basically, there are a lot of resources online. I'll leave a link in the description box as well on how you can download Eclipse and install. If you just watch a lot of their videos on how to install Eclipse or NetBeans or whatever you're using, and just feel free to install it before we go ahead in this series. So basically, one thing, like I said, is you start by creating a program in a text editor. Yeah? This, most times when you type in the text editor, syntax errors are just errors, um grammatical errors. Let me put it that way. So every language has its style of writing. Yeah? So Java has its own style, which we'll be digging into. So if, for example, you write a line that Java is not Java style, it would throw it up as a syntax error. Sometimes it could be spelling. You've spelled something wrong. Yeah? It will come out as a syntax error. So basically, syntax error are just correcting the grammatical errors as concerned with that language, if that makes any sense. Just think of it as syntax errors, grammatical errors, the language grammatical errors. It will point them out to you. We'll see some examples. They're what you call runtime errors. Runtime errors as well. We'll see an example. They're just after the program, the language or the high level codes you've written gets translated or compiled, yeah, into the computer's format. The next thing, like I said, it will now be in a format, an executable format for the computer to execute. Once that is done, sometimes there could be some errors. So it's compiled well, there was no syntax, it compiled properly. But then when it comes to executing that file, there are certain things that are going to prevent it. Maybe it's searching for a file that you've pointed it to. So there was no error in compiling that, oh, search for this file. But now in the runtime, when it wants to execute, it's trying to search for that file and it cannot find that file. So that is an example of a runtime error. It's going to throw an exception, or it's going to throw an error telling you this cannot be done. Yeah? So it's a runtime error. We also have the semantic errors. These are the most difficult errors when it comes to programming because they have to do with logic. So when you hear semantical errors, semantics is all about logic. What is the logic behind this? Is it the right logic? So most times semantic errors are logical, faulty, bad logic that to achieve what you want. For example, you have a program where you've defined what the radius is in your Java program, and then you've defined the circle area as 4 times radius times radius. Yeah? Basically, when you run this, the result is going to compile correctly if you write it in the right syntax of writing Java codes, which we'll go into. It will compile it correctly, but at the runtime, it will run because this is simple. It's quite simple. The radius is present, yeah, and we're going to input or it's meant to be inputting the radius, but then it will give you a result. But the result is actually wrong as opposed to if you were to do this by hand. You know that the circle area is pi r squared. Yeah. So ideally, you're supposed to define either what pi is, yeah, and you're supposed to, or you give it as 3.142, which is equal to pi times radius. That would be right. So this is an example of a semantic error, and they're very difficult to remove. Ways to remove semantic errors or find out semantic errors, if you want to learn ways, is through testing. So as a Java programmer, you're going to be doing a lot of testing. In testing, there are so many things to do or to learn about software testing. We have a software testing course. At just register on lovecodings.com and you'll be able to um, listen to or get in touch with the trainers for software testing. But one thing about finding semantic errors is that when you have to test the codes to find the semantic errors, you need to be able to, that's why I said programming, you need to be able to think logically. You need to be able to be someone that comes up with different ways of solving a problem. Think of different ways. You have to sometimes, one of the other ways that you've worked out your results by hand. You know what, like in the other previous example, in the circle area, you know what the answer should be. So basically, if it's coming up as a different answer, you know how to react to that. If you find out, okay, this is oh, my answer is wrong because I've worked it out by hand, you need to now start putting the different scenarios you've created. Okay, why is this happening? You do a lot of printing. You can print at each step. First do this step, yeah, print out and say, okay, tell me, is it actually assigning the right radius? So I've said in this other point that radius is equal to 10. So if I want to figure out why is the answer different here for the circle area when I print it out, I could go back and say, okay, print, after assigning the radius as 10, print out what the radius is for me, just to be sure it assigned it correctly. Those are like scenarios, for example, of trying to solve or resolve or find semantic problems or semantic errors. Yeah. So you take it, you break it down into different units, you test each unit, the program gently, and then you'll be able to fish out whatever the errors are. Also, show you an example of how an IDE looks. This is just an image, but we'll actually see the right thing on how an IDE looks shortly. The Eclipse IDE. So when you start up Eclipse for the first time, it's going to come and appear, or rather your workspace, you launch up Eclipse. Most times if you've not used it before, your workbench would appear like this. So we just want to go into our workbench. This is how Eclipse IDE looks. So you go into your workbench. Package Explorer view, where you'll be able to see a list of the current projects they're working on. So, and then you have the editor. This middle part is the editor. You have where you can see problems, your Java documents. There's a lot of windows to help you view several things. As we go on and proceed in this course, you'll be seeing how to make use of the different views in your IDE. So basically this course anyways is not going to teach about the windows or the programs. There are so many YouTube videos to understand what each window does. You can watch them on YouTube or you can Google and read about the Eclipse IDE. But I'm going to be showing us on how to use it in doing a simple or even starting with simple Java programs. So first of all, it's empty right now, our workbench, because this is the first time we're using this. So we just want to go to your package explorer and create a new, you want to just go here using this icon and create a new project. So if you just choose, you can just say create a new Java project. And then it will take you through a series of process. You have to give your project a name. So we're going to call this Love Codings, or we can just call it Java Love Codings. One thing about Java is that your project is a good practice to give your projects names that are understandable, for to remember what the project is about, and start the project name with a capital letter. So you can either use the default, and we've created the Java Love Codings project. So under this project, those are the Java library. This is the default Java library that comes with Eclipse, and it will help in our programming, Java programming. So basically, you don't really need to start going into details about all these different things available in the library. We'll go gradually. Like I said, don't be too hard on yourself. Just take it easy, one step at a time, and it will all make sense. So basically what we're going to do is to create our first class in Java. So classes in Java are objects. You have to start you running your program from a main object, and then it transitions into other, calling other objects or using other objects. Yeah. So when you hear class, creating a class, making a class, they're all different objects doing different things or performing different functions. And then when the whatever function they perform can be used in other classes. So the first thing first, when you want to start programming, like I said, this is the editor, is that you want to create in that your project folder, you want to be able to create a new Java class, the main class, where everything will be done. So if you're writing a simple program, you could program everything you want in your main and it will run. If you're writing a program that has to do with other classes, you would create other classes and then call the next class from your main that you want it to reference. That's like objects. Like I said, just think of it as objects. Everything is about objects. So we're going to create the first main object, which is the first main class. We'll just come on here and we'll just select class. So this is the source folder. You can give it a package folder. If you don't want to use the default, you can just create a source folder saying that that's where all your Java uppercase letter. And I'm going to call this test tutorial main. Yeah. So this is what I'm calling it. And next thing, because it's our main class, because it's an ID as well, you can just select that this is the main class, so it automatically generates and writes the main method or creates the main object in that class. Yeah, that's the main function of just to tell it something. Java needs something to show that this is the main, this is where the program starts from, this is where everything you need to do with your programming would link to. So to refer to it, it always has a syntax for the main, so it can generate it automatically for you in your IDE. You just need to select that and we'll click finish, and it's created the Java tutorial main, and this is it. So it's quite easy. So this is the first um objects that we're creating in our Java programming. We're going to see different types of errors in Java. So we'll go into more depth about talking about. So first thing first, this is an auto-generated comments. So you can make comments in Java using the double stroke line, forward stroke. We'll see an example. So we just want to see different types of errors. So we'll go a little bit more into more details in our next tutorials on variables, on the syntax, the language itself, the syntax. We'll go into details about the just basically the language, how to define variables, how to create objects, how to create, aside not just about the creating the main object. For example, you may want to create a simple object called radius where you store the radius of the circle. Yeah, so it's like creating different containers. So basically, but in this first introduction, I just want to show us samples of errors that you could have. So I'm writing this code in the IDE. Like I said, IDEs make your life a lot easier. Trust me. Just use an IDE as often as you can because your life would be a whole lot easier. So in this IDE Eclipse, like I said, an IDE, as you're typing, it's telling you what your syntax error is. If you just hover over that, it will tell you the error. So because obviously in Java language, everything has to be terminated, or every statement you make, or most statements have to be terminated with a semicolon. All statements, rather. We're going to see more details about that. They have to be terminated with a semicolon. What if I remove that semicolon? That's a syntax error. That's a grammatical error. It's not correctly right in the language. So IDs will help to point you easily, so which makes your life a lot easier. You don't have to start remembering every single thing. It will tell you where the syntax error is. And what I'm saying here is just simple print out to the system hi for me. So I'm going to run this. Because this is the first time and I haven't saved it, I would save. And then it would run. So basically, all your results in Java are printed in the console, or rather when you're writing, if you use the system, the built-in method for printing, yeah, onto the system console. You can use this for testing once you're doing your codes and everything. Like if you want to check for semantic errors, logical errors, you can do a lot of prints so that it will tell you at different points. It's just a way of troubleshooting. So this is run fine now, and we can see hi being printed out in the system console. So what we're going to do next is see an example of a runtime error. So I've just taken out the static. So every main class or main, so this is the main class called tutorial main, the main object where everything starts. Everything where the method that fires up the system or the program to start running is the main method. The main method fires it up. I've said that. It has a particular way it has to be called or used or written. Now I've written this. It seems like, oh, there's no syntax error. And I'm going to run this now. But then I get an error in red telling me the main method is not static in class source. Please define the main method as this. Tells you what the main method should be. So this is an example of a runtime error. The code, everything seemed fine, like no syntax error in terms of like just looking at it, like, oh, it's okay. Yeah. But the fact that it's looking for the main as a um as a static um it's looking at the main, yes, as a static object, yeah, and it can't find it as a static object. It's finding it just as a void object, public object. So you need to define. So this is, it won't allow it print out hi for me. It's an example of a runtime error. So I'm going to put this back, and then that's it. It will run fine again if you run this. So an example of a semantic logical error, let's just do an example. So I'm going to give, say I declare a name. We'll go more about the language in later tutorials about writing or declaring variables. I will explain more later on what all this means, but I want to show us an example of a logical error. So now what I want to do with this code, I've got a name I want to print out, and I'm telling my system to print out, and the name I want to print out is Lami. I want to say hi to Lami. Yeah, I put a comment that this program should say hi to Lami. That's the whole purpose of the program, to say hi to Lami. Now I go ahead and I type this without realizing that, oh, I've done that, and I say this. Yeah, so basically what I've done here is, if I run this now, I'm just going to run this to show you that the whole purpose has been defeated of what I want to achieve. Yeah, I run this and it's saying bye Lami. I don't want it to say bye Lami. I want it to say hi Lami. That is an example of a logical semantic error. Another example we would use is the example of our radius, or the circle. I'll correct. I'm going to put this. So say I have a radius of 2, and I want to calculate the area of a circle, and I've said the area of the circle is going to be 4, back to our example, times the radius times the radius. That's saying 4 times radius square. We know it's pi times radius square. Sorry. Yeah, so basically now I'll just go ahead and say it should print out what the area is for me, and it's printing out 16, because what it's done here is, so it's giving me, it's compiling well, it's running well, and it's telling me, oh, the area of the circle is 16, but that's not right. The area of this circle is not 16 in any way. So to this, all I'm just going to do is to make this area to return as a double. So it's going to give me the area in points. So there's so many ways of doing things, to make your work easier. So basically this is the right area that I calculated by hand previously, 12.58. So that's an example of a logical error. So you bring up so many scenarios or so many ways and try to figure out, okay, why is the answer giving me what's wrong? You could print at so many points, you could print out the radius of assigning it, and so on and so forth, to return as a double. So it's going to give me the area in points. So there's so many ways of doing things, to make your work easier. So basically this is the right area that I calculated by hand previously, 12.58. So that's an example of a logical error. So that's it, guys. That's an example of a semantic error, of a syntax error. We've seen an example of a runtime error. So in our next tutorials, or the next tutorial, we're going to be covering variables. We'll start creating and talking about variables and all the different kind of objects that we have in Java. Thank you for listening. If you want a link to other documents, I'm going to put it in the description box below the videos. A link to the Java 8 API, to Eclipse, everything you need to start up with using your Eclipse for Java programming. Thank you.